In this tutorial, we'll learn about NumPy's random module and explore how to generate random numbers. First, import NumPy as NP so we can access its random functions and numerical tools throughout the tutorial. Now, type np-random to access NumPy's random module, which contains functions for generating random numbers, random arrays, and probability distributions. We import NumPy as NP to use its numerical and random functions. Then, we set the random seed to 42 using np random seed 42, which ensures the same random numbers are generated every time the code runs. Finally, np random ran3 generates an array of 3 random numbers between 0 and 1 and print displays them on the screen. np random ran5 generates an array of 5 random floating point numbers between 0 and 1. Each time you run the code, NumPy creates random decimal values that can be used for simulations, testing, or machine learning experiments. np random ran2 3 generates a two-dimensional NumPy array with 2 rows and 3 columns filled with random floating point numbers between 0 and 1. Each value in the array is randomly generated, making it useful for creating sample datasets, testing algorithms, and performing simulations in data science or machine learning projects. Every time the code runs, different random values are produced unless a random seed is set beforehand. np random random1 10 generates a random integer between 1 and 9. In this function, the starting value 1 is included, while the ending value 10 is excluded. It is commonly used when you need random whole numbers for testing, simulations, games, or generating sample data in Python programs. np random random1 100 size equals 5 generates an array of 5 random integers between 1 and 99. The first value 1 is included, while 100 is excluded. The size equals 5 parameter tells NumPy to return 5 numbers instead of just 1. This is useful when you need a list of random whole numbers for testing, simulations, or creating sample datasets. np random random 0 10 size equals 2 3 generates a 2x3 NumPy array filled with random integers between 0 and 9. The starting value 0 is included, while the ending value 10 is excluded. The size equals 2 3 argument specifies that the output should have 2 rows and 3 columns. This is useful for creating random integer matrices for testing, simulations, or data experiments. np random ran5 generates an array of 5 random values sampled from a standard normal Gaussian distribution, where the mean is 0 and the standard deviation is 1. This means most values will be close to 0, but some may be larger or smaller in either the positive or negative direction. The output is different every time the code runs unless a seed is set. This function is commonly used in machine learning for initializing weights in neural networks, running statistical experiments, and simulating real-world data that follows a bell-shaped distribution. np random random2 3 generates a 2x3 NumPy array filled with random numbers drawn from a standard normal Gaussian distribution with a mean of 0 and a standard deviation of 1. The values in the array can be positive or negative, and most of them tend to cluster around 0, with fewer extreme values farther away from the mean. The 2x3 shape means the output has 2 rows and 3 columns. This function is widely used in data science and machine learning for tasks such as initializing neural network weights and simulating normally distributed data. np random choice here randomly picks a single value from the array 10, 20, 30, 40. Each element has an equal chance of being selected, and the result can change every time the code runs unless a seed is set. This function is useful when you want to simulate random selection from a dataset, create random test samples, or model situations where outcomes are chosen from a fixed set of values, such as games, lotteries, or bootstrapping in statistics. np random choice here size equals 3 randomly selects 3 elements from the array 10, 20, 30, 40, and returns them as a new NumPy array. The same value can be chosen more than once because the default behavior allows replacement. This function is useful for random sampling, simulations, and generating test data where you need multiple random picks from an existing dataset. NP random choice here, size equals 3, replace equals false, randomly selects 3 unique elements from the array 10, 20, 30, 40 without repeating any value. Because replace equals false is used, each element can only be chosen once, so all selected values are distinct. This is useful when you need random sampling without duplicates, such as picking a subset of data or selecting unique items from a list. NP random choice 1, 2, 3, size equals 10, P equals 0.2, 0.5, 0.3, randomly selects 10 values from the list 1, 2, 3, based on the given probabilities. The P parameter controls how likely each value is to be chosen. So 1 has a 20% chance, 2 has a 50% chance, and 3 has a 30% chance of being selected each time. The result is an array of 10 randomly chosen values, where some numbers may appear more often than others depending on their assigned probabilities. We create a NumPy array containing the values 1, 2, 3, 4, 5. Then, NP random shuffler randomly rearranges the elements of the array in place, meaning the original order is changed directly. Finally, printer displays the shuffled version of the array. Each time the code runs, the order of the numbers will be different. We create a NumPy array containing the values 1, 2, 3, 4, 5. Then, NP random permutation R returns a new shuffled version of the array without changing the original one, and we store it in new air. Finally, we print both arrays. New air shows the randomly rearranged values, while air remains unchanged in its original order because permutation does not modify the original data. NP random uniform 1, 10, size equals 5 generates an array of 5 random floating point numbers between 1 and 10. Each value is chosen from a uniform distribution, meaning every number in the range has an equal chance of being selected. This function is useful for creating random continuous data in simulations, testing, and data science applications. NP random normalloc equals 50, scale equals 5. Size equals 10 generates an array of 10 random numbers drawn from a normal Gaussian distribution. The LOC equals 50 sets the mean center of the distribution to 50, while scale equals 5 sets the standard deviation, controlling how spread out the values are. The size equals 10 argument means 10 values are generated. This is useful for simulating real-world data that tends to cluster around an average value with some variation. NP random binomial 10, 0.5. Size equals 5 generates an array of 5 random values from a binomial distribution. In this case, each value represents the number of successes in 10 independent trials, where each trial has a 50% probability of success, p equals 0.5. The result shows how many successes occurred out of 10 attempts, and this process is repeated 5 times. This function is useful for modeling yes-no experiments, such as coin flips, pass-fail tests, or other binary outcomes in statistics and simulations. NP random Poisson lim equals 5. Size equals 10 generates an array of 10 random numbers drawn from a Poisson distribution. The lim equals 5 parameter represents the average rate mean of events occurring in a fixed interval, so the values will typically cluster around 5. Each number shows how many events happen in each trial, and the results can vary above or below the mean. This function is commonly used to model count-based data, such as the number of arrivals, requests, or occurrences over time. NP random exponential scale equals 2, size equals 5 generates an array of 5 random numbers drawn from an exponential distribution. The scale equals 2 parameter controls the average value mean of the distribution, meaning most values will be small but occasionally larger values can appear. The size equals 5 argument specifies that 5 samples are generated. This function is commonly used to model waiting times between events, such as time between arrivals in queues or lifetimes of certain processes in simulations. NP random beta equals 2, b equals 5. Size equals 5 generates an array of 5 random numbers drawn from a beta distribution. The parameters a equals 2 and b equals 5 control the shape of the distribution, causing most values to be closer to 0 while still staying between 0 and 1. The size equals 5 argument specifies that 5 samples are generated. NP random gamma shape equals 2, scale equals 2, size equals 5 generates an array of 5 random numbers drawn from a gamma distribution. The shape equals 2 parameter controls the form of the distribution, while scale equals 2 stretches or shrinks the values and affects the mean. The size equals 5 argument specifies that 5 values are generated. This function is useful for modeling waiting times, continuous positive data, and processes where values are skewed and cannot be negative, such as rainfall amounts or service times. NP random squared equals 2, size equals 5 generates an array of 5 random numbers drawn from a chi-square distribution. The df equals 2 parameter represents the degrees of freedom, which controls the shape of the distribution, making the values skewed to the right with only positive numbers. The size equals 5 argument specifies that 5 samples are generated. We define a mean vector, 0, 0, which represents the average values for two variables. Then, we define a covariance matrix cov that controls how the two variables vary together, where the diagonal values show individual variances and the off-diagonal values, 0.5, indicate a positive relationship between the variables. Next, NP random multivariate Normanian, cov. Size equals 5 generates 5 samples from this joint distribution, where each sample contains 2 correlated values. Finally, print samples displays the resulting 5 rows of paired random values. Matrix equals NP random rand 3. 3 generates a 3x3 matrix, 2D array filled with random floating point numbers between 0 and 1. Each value is independently sampled from a uniform distribution, meaning all numbers in that range have an equal chance of appearing. Tensor equals NP random rand 2, 3. 4 generates a three-dimensional NumPy array, often called a tensor filled with random floating point numbers between 0 and 1. The shape, 2, 3, 4, means it contains 2 blocks, each with 3 rows and 4 columns. Every value is independently sampled from a uniform distribution, so all numbers between 0 and 1 are equally likely. You have successfully completed the NumPy random tutorial, which provides an overview of generating random numbers, arrays, and samples. We covered functions for creating random floats and integers, sampling from specific distributions like normal, uniform, binomial, Poisson, and more, as well as shuffling and selecting elements from arrays. This foundation is useful for simulations, statistical modeling, machine learning, and testing in Python projects.